Let's go to page 737 and start with number 15. Okay, so you have the A, D, D, E, and D. Okay, and you want to find the number of ways that the letters of each word can be arranged. Okay, so they are repeated items. So there are 2, 4, 6. So there are a total of 6 letters. So it would be 6 factorial. Okay, but there are 3 repeats. So you have to divide by 3 factorial. There are 3 D's. And so this will equal to 120. Okay, okay, number 17. Okay, you have rotor. Okay, so there are 5 letters. So the maximum you have, the total is 5 factorial. Oh, wait, number 17. Okay. Yeah. Okay, and then there are 2 repeats, so it will be 2 factorial. So use your calculator, you figure out so they equal to 30. Okay. Okay. Number 19. Mississippi. Okay, so number 19, okay, so you count the letters. So there are 11 letters, so it will be 11 factorial. Then you have to divide by the repeats, because when you switch the same letter, it doesn't have a new word, okay? So there are 4 S's, so let's tally it up, and there are 4 I's, there are 2 P's, and 1 N. Okay, so there are 4 S's, so you have to divide by 4 factorial, and there are 4 I's, divide by 4 factorial, and you have 2 P's, you have to divide by 2 factorial, and 1 M, you have to divide by 1 factorial, but when you divide by 1 factorial, it doesn't do anything. So technically, you have to do this, okay? So you can 4, 4, 2, 1, 4, 4, 2, 1. But again, this one doesn't do anything. So use your calculator, work it out. Okay, so you're going to get 34650. Okay, let's go to 21. Okay, 21 is you have to be very careful. 21 is not too bad. So you got the flag, there are 5 flags, so it'll be 5 factorial. And you have to divide, there are 2 red ones, so you have to divide by 2 factorial. There are 2 white ones, so divide by 2 factorial, and 1 blue one. Again, you don't have to write this, but I'm just writing it so you can follow. Okay, so this will equal to 30. Okay. Okay, let's go to number 23. 23, you have to be careful. There are three emeralds, 2 diamonds, and there are 2 different opals. So when there are 2 different opal, means you're going to get 1 opal and another opal. There are 2 different ones. Okay, so there are a total of 7. So you get 7 factorial divided by 3 factorial, 2 factorial. Now you cannot divide by 2 factorial because they are not the same. Okay, they are all different. Okay, so you have to be careful. So you're going to get 1 factorial, 1 factorial. Okay, because here your 2 opals are different. Okay, so if identical, you lump them together, then you have to divide. Okay, and so this will give you 420. Okay. Okay, let's go to the next one. Okay, so number 25, you want to show that 6p4 is equal to 6 times 5p3. So what you do, you use the definition of the permutation. So npr equal to n factorial divided by n minus r factorial. So that's the definition you have to use. So 6p4 will give you 6 factorial over 2 factorial, right? You have to subtract. This will equal to 6 times 5p3 will give you 5 factorial over 5 minus 3 will give you 2 factorial. Now notice 6 times 5 factorial. 6 times 5 factorial is equal to 6 factorial, right? Because 5 factorial is 5, 4, 3, 2, 1. So 6, 5, 4, 3, 2, 1 is 6 factorial. So again, this times that equal to that. Okay, if you don't see that, you go to the side, see 6 times 5 factorial. Okay, this is equal to 6 times 5, 4, 3, 2, 1, right? That's what this is, right? Well, what's this? Well, this is equal to 6 factorial, right? So that's how I get from here to here, okay? And once they are same, put a check mark, okay? Okay, let's go to next one. Okay, number 27 is a little bit more challenging. So because you got variable. So MP5 minus MP4 equal to n minus 5 times MP4. Okay, so first let's go and just write out the definition. So this will equal to n factorial over n minus 5 factorial. This would be n factorial over n minus 4 factorial. Okay, and this would be n factorial over n minus 4 factorial. So I'm just writing out a definition, right? Using this over here, right? That's your definition for factorial. Then I'm going to write out a few terms. So n factorial, n minus 5 factorial would be n minus 5. And you have to get one less, would be n minus 6. N minus 7, dot, 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 okay? And do the same thing over here, so you got n minus 4, n minus 5, n minus 6, dot, 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 dot. Okay, and this side, I'm just going to leave it the same. This one is going to be n minus 4, n minus 5, n minus 6, dot, 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 okay? Now, to make this side match with that, we need to add this together, so, okay, or subtract together. So to subtract fractions, you need to get your common denominator. So from here, your LCD would be n minus 4, n minus 5, n minus 6, dot, 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 right? N minus 7, just continue, okay? Okay, let's do this then, okay? Now, so now you have to, once you get your common denominator, you have to figure, okay, how are you going to get from here to here? To get from here to here, you need to multiply by n minus 4, right? Because right, this one is missing n minus 4. So that means the top would becomes n factorial times n minus 4. Okay? Minus, this one have everything already, so this one you don't have to do anything. Okay? So let's not do anything with this over here for now. Okay, then after that I'm going to factor out the n factorial, so I get n minus 4 minus 1, right? Again, when you factor everything out, it's 1, okay, over n minus 4, n minus 5, n minus 6, dot, 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 okay. Okay? Okay, so now I can work this out. And since I have this in the front, so I'm going to put this in the front. So I'm going to have n minus 5, n factorial, over n minus 4 factorial, right? That's what this is, right? Equal to, again, this one I'm going to have n minus 5, n factorial, and bottom is n minus 4 factorial, right? Again, that's what this is, okay? And now the both sides are the same, so put a check mark, and we're done, okay?